Good afternoon, boys and girls. It's time to go over our DMA Week 33, Day 1 solutions. So if you want to go ahead and let's get started with our first problems for Day 1. So you will notice that in our first problem, it's a fraction comparing problem. So it asks you to write a less than. Remember, you can use a L for your fingers to use as a less than symbol. So less than, greater than, or equal to symbol to make the statement true. So in this case, we have 5/8 compared to 1/8. So if we use our understanding of modeling, we know that our denominators are both the same of the whole. So if we used a rectangle and we used a rectangle, one whole rectangle over here, remember we're comparing the same whole. I'm a little off on my lines today. That looks better. And we are going to partition each whole into eighths, which means 8 equal pieces. So we would normally start off with half so that we can partition it into fourths. So we're going to take each half and partition it into 2 more pieces to make fourths. Then once we've partitioned the fourths, then we can partition them into 2 more equal pieces to make eighths. And each one of these is a 1/8 part of the whole. So we could we could label these as 1/8 parts in our whole. Now, in this case, we have 5/8. So we have labeled 5 of our eighths. The numerator tells us how many of those partitioned pieces we are showing. In our second whole, we're going to do the same thing. We're going to partition it in half first. Then we're going to use our understanding of fourths, partition each one of those fourths into eighths. Now we have 8 equal pieces, which is what our denominator tells us here. Now we're going to look at our numerator. Our numerator tells us how many of those partitioned pieces that we want or want to represent, and we want 1 of the 8 pieces. So when we look at 5/8 compared to 1/8, we know that 5/8 is greater than symbol 1/8. So now our statement or our equation is true. I'm going to skip for right now our word problem, and I'm going to go down to our rectangle here, which is a quadrilateral. And our quadrilateral, for this quadrilateral, they want us to tell what the area is of the rectangle. That means how many square units of space does this rectangle cover or represent? So if we remember, the 4 tells us how many rows we have, and the 7 tells us how many columns we have. Now, if we think about our rows, we have 4 rows of squares and 7 squares in each row. So we could say 1, 2, 3, 4, 5, 6, and the last row is 7. So if we have 4 rows of squares with 7 squares in each row, we know that this is a multiplication equation because we have 4 groups and we have 7 squares in each of the groups, which is our rows, and we have 28 squares total. And we're going to label these units because we don't know if these are square inches, square centimeters. they don't give us the measurement. Now, if it said cm here, we would know that those are centimeters. If it was in, we would know it would be inches. If it was m, we could say it's meters. But in this case, we don't know, so we're going to say 28 square units. So we're going to use, the A is representing area, and we know that there are 28 square units of area or space being covered inside of this rectangle, this quadrilateral. Now, just to remind ourselves, if they had asked for perimeter, and I think that's why they put the 7 and the 4 here, just to kind of throw us off by thinking, well, okay, do they remember what area is? If they were to ask for perimeter, we would take the length of each one of these lines or sides, and we would add them together to find the perimeter, which is the distance around this rectangular figure. So now let's take a look at our multiplication sentences or equations here. We have 30 groups of 1, or we can use our understanding of the commutative property and switch these. We could have one group of 30. So if I were to draw myself a model, a bar diagram, I'd have one group with 30 in that group. So one group of 30 is 30. We could also do 1 times 10, because 10 times, or we could use our basic fact, 1 times 3, or 3 times 1, and then multiply it by 10. So 3 times 1 is 3, and 3 times 10 is 30, which is also still going to give us how many total are in one group of 30. In 60 times 9, we have 9 groups of 60, or 60 groups of 9. Much more efficient if we were to add groups of 60. So we could say with a bar diagram, 60 plus 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 60. So that's 1, 2, 3, 4, 5, 6, 7, 8. 9 groups of 60. Now, to be more efficient, we would probably want to use our understanding of our basic fact, which is 6 times 9. 9, not 10 yet. 6 times 9, and then we multiply that by 10, because we're taking that 60, and it's 6 times 10 makes this 60. We're just breaking up this 60 as 2 factors to make this easier for ourselves to hopefully figure. So our calculations for 6 times 9 would be 54, and 54 times 10. So 10 times 4 is 40, and 10 times 50 is 500. So that would give us 540. Same thing for 8 times 5. We could have 5 groups of 80. If we need to go the long way and use our understanding of repeated addition, we can do that. We know that our 2 groups of 80 is 160, 2 groups of 80 is 160, then add another group of 80, and this is going to give us 320 plus 80 should be 400. Or we can take our understanding of our basic fact of 8 times 5, so 8 times 5, and multiply that by 10. So 8 times 5 is 40, multiply that by 10, and that will give us 400. Now, if we take our word problem now, let's take our word problem, and it says Donna has 32 new CDs, and her CD carrier holds 4 CDs on each page. How many CD pages will she need to hold those CDs? So if we are taking what we are showing important information, we have 32 CDs, so we have a total of 32 CDs, and we have a carrier that holds 4 CDs on each page. So if we were to just take our understanding of a page, we would have 4 on that page, so that makes 4. And each one of these is a CD. So we have 4 CDs on that page. We have 4 CDs on this page. So now we're at 8. We take another 4 CDs and place it on this page. And again, you can represent this using a bar diagram also. So if we wanted to take each bar and represent it as a page with 4 CDs on that page, you can also do that. I'm just trying to make this a little more visual. Again, 4 CDs on that page, so we were at 4, 8, 12. Another 4 CDs would be 16. Another 4 CDs would be 20. Another 4 CDs would be 24. And again, if this is what you need to do to visualize it, that's okay. Another 4 CDs, we're at 24. Now we're at 28. And finally, if we add another 4 CDs, and I'm using my lines to kind of help me partition it neatly, another 4 CDs would be 32. So I have 4 groups of 4 and 4 groups of 4 again, which makes your 8 groups of 4, and that would be 16 and 16, so 16 and 16 makes your 32. So how many pages did she use? She used 1, 2, 3, 4, 5, 6, 7, 8. She used 8 pages for her CDs. So if we took our 32 CDs and we divided them equally onto 4 CDs each page, and I'm just going to abbreviate page here, that would give us 8 pages or 8 groups. So here's our groups, here's our number in each group, and here is our total. And you can use your understanding of multiplication to figure that out. So these are the number of pages. So we could put a P there for page. Okay, well that'll do it for day 1. We'll see you again tomorrow for day 2, week 33 on our DMA. Have a great day.